Hey guys, welcome to 9.1. It's the first video in Unit 9 on chemical reactions. In this unit, or in this video, we're going to be learning about the parts of a chemical equation, and then we're going to practice writing out chemical equations from a word equation, and then also we're going to write the chemical equation when we're given the word equation as well. So let's talk first about the parts of a chemical equation. Well, some of this, in fact, probably a lot of this, will be review for you, which would be great. But there are really three parts to a chemical reaction. There's the arrow right here, which is called the yield sign. The yield sign is really our separation between our reactants and our products. Anything to the left of the yield sign, so all of these compounds and elements, they are termed our reactants. So reactants are to the left of the yield sign. And then anything to the right of the yield sign is termed our products. So anything before are what we start with in the reaction, and then that yield sign represents that these two reactants are actually reacting, and then products are what we have left over. Something else I want to point out to you is down here I have a list of important vocabulary, and so I'm going to be going through defining these terms for you, but I will not write them on the screen. So as I describe these words to you, write them in your important vocabulary section. So yield sign is our separation between the reactants and the products. Our reactants are what we start with at the beginning of a reaction, and our products are what we end with, or what we form after the reaction is over. Okay, so two other terms are subscripts and superscripts. Subscripts are the small numbers at the bottom right-hand corner of these subscripts. Merely represent the number of atoms that are inside of that formula. For example, this formula says CH4, meaning that we have 4 hydrogen atoms. Now, there's another term called superscript. If I showed you a polyatomic like PO4 on the periodic table polyatomic chart, you'll see this written there, PO4. That 4 is the subscript, okay? That is how many atoms of oxygen are inside of this polyatomic, okay? But then you'll also see a number right here. You'll see like 3 negative. That 3 negative is the superscript. It's the number on top, okay? A superscript is representative of the charge of the atom. Okay, the next term is the term coefficient. I'm going to change colors so that you can see this. A coefficient is the number that is, I always call it, it's the big number. It's the number that's normal sized. It's not really tiny like a super or subscript. And it's to the left of a compound. This is our coefficient, and it refers to the number of molecules, okay, the actual number of molecules. So here it says we have 2 H2Os. So what that means is that here is 1 H2O molecule, right? And then here's another H2O molecule. So you can see we have 2 H2Os, and we represent that with this big number 2 in front of the compound. Now that's the literal definition for a coefficient. Remember how I told you in a reaction we never just take one methane atom and combine it with 2 O2 atoms to get 1 carbon dioxide and 2 waters. Like, that's impractical, right? So most of the time, even though the 2 does refer to the number of molecules needed to react, or the number of molecules produced, it also can refer to our number of moles. That's a more practical way. So another way I could describe this reaction is I could say 1 mole of CH4 could react with 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water. So it literally, it refers to the number of molecules. Practically, it refers to the number of moles. The only other set of definitions I want to go over are these symbols in parentheses. These are referred to as the states of matter. So for example, if our compound is existing as a solid, we would put a little S after it to represent that it is a solid state. The L stands for liquid, and the G stands for gas. Now there's one other state of matter that we use, and it's represented by AQ, and it's called aqueous, which just means something dissolved in water. Okay, so we're now going to practice writing out a word equation if we're given a chemical equation. So the chemical equation is referred to as the equation that has the symbols, the formulas, the numbers, the coefficients, all of that. That's referred to as a chemical equation. A word equation is one like down here, where we actually use real words to explain what's happening in a chemical equation. So in a word equation, there's a few things that you need to remember when you're writing it out. It's 2 moles of silver nitrate. The 2 is going to stand for the number of moles. So here I write 2 moles of. This AQ is my second point. So it says, we did the moles, okay, now we have to do the state of this thing. So I have to say AQ means aqueous. So I say 2 moles of aqueous, and now I write the name. That's my third part. So what's the name of AgNO3? Well, Ag stands for silver, so I write silver. And then NO3 stands for nitrate, so I write nitrate. You have to remember that if you have a transition metal, you have to write the charge as a Roman numeral in parentheses. Silver is a transition metal. How do I find its charge? Well, you don't know its charge, but you do know the charge of what it's bonding with. For example, I'm going to write this just up here so I have more room. So here's silver. We do not know its charge, but we do know nitrate's charge. Nitrate, if I look on the polyatomic chart, its charge is -1. Okay, so this whole thing is a -1 charge. So what does silver's charge have to be in order to even that out? Well, if nitrate's -1, silver would need to be +1 to even that out. So I'm going to write in here its charge is 1. And that's the Roman numeral 1 that I wrote. So 2 moles of aqueous silver nitrate. Okay, now I come to a sign. Anytime you come to the plus sign on the reactant side, so here's my plus sign on the reactant side, I have to basically write that out in words. The plus sign on the reactant sign means reacts with, and so I'm going to write reacts with here. Reacts with. So far I have 2 moles of aqueous silver 1 nitrate reacts with. Now I'm going to begin my method all over again. So anytime you come to a new compound, you have to begin this method: moles, state, and name. So how many moles of this next compound do I have? Well, there's not a number in front, so we assume that it's 1 mole. So I write here, with 1 mole. Remember, there's not a number right here, so I'm going to assume it's 1. So the next thing I do is I write down my state. The state of this is a solid. And by the way, I didn't mention this, but I did not type out the states of matter on your paper. So if you could just write them in so you have them, that'd be great. So 1 mole of solid, so I have to write that next, solid. And now, what's my third step? It's to write the name. So my name is, I have to look this up on the periodic table, not the periodic table, sorry, the polyatomic chart. And NH4 stands for ammonium. So I write ammonium. And then this part here, CrO4, I have to, again, look on the periodic table. It is a polyatomic, so I name it, and its name is chromate. Remember, if you ever have polyatomics, you just name them, okay? So ammonium chromate. And now I come to another symbol, and this symbol is the arrow. And the arrow always stands for produce, okay? So far I have 2 moles of aqueous silver 1 nitrate reacts with 1 mole of solid ammonium chromate. And then I'm always going to write to produce, to produce. That's my arrow. My arrow stands for to produce. My plus sign stands for reacts with, okay? So now again, I start my 3 steps over again. I have to write the moles of this compound, then the state, then the name. So how many moles of AgCrO4 do we have? Well, there's not a number, so I'm going to assume it's 1. So I write 1 mole of, and now I do my state, and my state is a solid, so I write solid. Then the last thing I do is I name it. So Ag is silver again, so I write silver here, 1 mole of silver. And then the second part is chromate. Now, I have to watch out. This is a transition metal, so I have to write the charge of silver. Well, I already know the charge of silver from before, okay? And so that silver is going to have the same charge, and that's silver 1 in parentheses. Sorry, that's messy. Silver 1 chromate. And then this, we run into another symbol. this symbol here we're just going to refer to as and. Because what are the two things we're producing? We're producing AgCrO4, and then we're also producing NH4NO3. So I write, we're producing 1 mole of solid silver 1 chromate, and now again I start my steps all over again. Now step number 1 is moles. So I have to write 2 moles of, and the second step is to write the state. So I write the state of this, which is aqueous. Oops, it's UEOU, of aqueous. And now I write my name, okay, NH4 is ammonium, and NO3 is nitrate. Okay, so that is one example of writing out the word equation when I'm given the chemical equation. So this next problem is on your own, so please make sure you work on that. Pause the video now, work through that problem, and then restart the video and I'll work on to our next example. Okay, so now we're going to learn how to write the chemical equation when we're given the word equation. Whenever we're writing the chemical equation, we have to follow 4 steps, and I wrote them up there at the top, so please write them on your paper. Okay, so let's start with number 1. We write the symbols for each of the calcium chloride is my first reactant, so I write it out. Calcium's charge is Ca. Chloride is Cl. Remember, if it ends in IDE, it's on the periodic table. It's an element on the periodic table. The only exception is hydroxide. Hydroxide, even though it ends in IDE, is a polyatomic. Okay, so I've just wrote the symbols. I'm not going to even out the charges or do anything. Reacts with is my plus sign. So I write plus. Now I read aqueous silver nitrate. So silver and nitrate. So silver is Ag. Nitrate is NO3. Again, I'm not evening out charges, I'm just writing out the symbols. Now to form means, it's going to be a sign. To form means our yield sign. And then we have silver chloride, so I write AgCl. And here's my and. My and is the plus sign. Calcium nitrate, CaNO3. So I've done the first step. I've written out my symbols. Now I need to write out my charges, okay? So my charges, I'm going to have to look on my periodic table and my polyatomic chart. So in my periodic table, calcium is in group 2. Anything in group 2 has a +2 charge. Calcium's in group 17. Anything in group 17 has a -1 charge, okay? And since these charges aren't even, I need to add another chlorine so that I have a -2 charge to counteract the +2 charge. So since I have 2 chlorines, I'm going to add a 2 right here. Okay. Now, silver. Silver is not a polyatomic. It's a transition metal, so I don't know its charge, so I have to find it. It says right here, silver 1, so my charge for silver is +1. Now, nitrate is a polyatomic, so when we look on the chart, it says its charge is -1. Since these numbers are even, I don't need to add any subscripts, so I'm good to go. I'm going to go ahead and scratch out my charges once I'm done with them. Okay, now on the next side I have silver again, and I see that its charge is 1. Calcium is on group 17, so its charge is also 1, so they're even. Don't need to worry about them. Next compound, calcium's charge is +2, like I said before. Nitrate, which we said before, is -1, and so we see they're not even, so we need to add another nitrate. So I need to add a 2 somewhere on here to show I have 2 nitrates, so I'm going to put parentheses and write the 2 on the outside. Okay, so we've done step 1 and step 2. Step 3 is to write the states of each of them. So I have to go back to my word equation and look at the states. It says solid calcium chloride. So down here I write parentheses and I write an S to represent that it's solid. What about AgNO3? It says it's aqueous. Aqueous means I write AQ at the end. Okay. Silver 1 chloride dissolved in water. What does dissolved in water mean? It means aqueous. So I write AQ here. And then calcium nitrate, it says it's a solid, so I add the S at the end. So we've done symbols, charges, states, and then moles would be the big number that I would put here. So if for some reason I said 2 moles of calcium chloride, then I would have put a big 2 here, okay? But I did not give you moles, so we're just not going to do step 4. Okay, so you have an on your own problem. Go ahead and write the chemical equation for this word equation on your own. And that is it for 9.1. Y'all have a great day.